Welcome to another video. In this video, I'm going to use the same question, the same functions, that is y equals x squared and y equals 0 and x equals 2, to explain the idea of a disk, a washer, and a cylindrical shell. Okay, so this is it. This is y equals x squared, and I am bounding it by the line x equals 2 and the line y equals 0, which is the x-axis. So the region I have shaded is the region that is enclosed by these three functions. So what I'm going to do is rotate this function about two different axes, and it will create two different shapes. Now, one of those shapes is going to be something we can find using the washer method, and the other one is going to be something we can find using the disk method. Okay, now whichever method you use, whether disk or washer, remember the universal one is the cylindrical shell. That's the one you should master, because the cylindrical shell will work even when the disk will not work, or when the washer will not work. Okay, so you want to learn it. So what I'll do is I'm going to do the disk and the cylindrical shell, then I'll do the washer with the cylindrical shell, or in reverse order, however. Okay, so let's get into the video. So let's take the very first one. I'm going to take this solid, okay, this area, and rotate it about the y-axis. Okay, so let's make that the first one. Let's call it about the y-axis. Okay, remember you have to be able to sketch whatever you're talking about. So this is going to go as far out as here, so something like this. You need to sketch something that goes like this. Okay, something like that, and it's going to curl down like this. And so this is just all imaginary. Okay, the real part that you're rotating is this, but you're going to have a shape like this. Okay, if you rotate it this way. So that's what we've got. It's a bowl, but the solid part of it is the lower part. So it's more like a bowl that has a solid inside. So if you want to find the volume of the solid that's generated, you'll notice that if you look into the bowl, it is thick on the inside because you can't go deep enough. This thing is going to keep stopping you. So you have two radii. There's an inside radius and there's an outside radius. Those are the two things you need to identify. Because you have two radii, because there's a hole in the middle or a hollow in the middle, it is not a disk. Because if you slice this way, you're going to get a washer. You're going to get something like this. Okay? At every point, you're going to get a washer. At every point from the top until you get to the bottom of it. So because you're going to get an inside radius and an outside radius, you just need to know what those two radii are. Okay? So the outside radius is usually the bigger radius. So we call it the big R. So we're going to say the distance from here to here is the outside radius. You see this? That is the outside radius. And the distance from here to the inside here at any point is the inside radius. Okay, so remember, it's more like a cylinder that has been chopped out. Okay, so what do you call this area? It is just pi r squared, but we have two r's. So we're going to say our integral is going to be pi. Instead of saying r squared, it's going to be big R squared minus small r squared. That's how we write it. Okay? Now, is it going to be dx or dy? Remember that the thickness or the height of the cylinder is in the y direction. So you just say it's going to be dy. That's all. Because the height, just look for that. Each of those washers that you cut off are going to stack up vertically, and that's going to be dy. So your job now is to identify what the big R is and what the small r is. So let's do the work here. Okay, the big R is going to be the distance from here, and you know that you see that it's consistent. It's 2. So the big R equals 2 no matter what you do. It's the small r that's changing. It's smaller here, it's bigger here, depending on this function. So actually, what is this function? Because you're measuring along the horizontal, what is this function in terms of x? Well, this is that function, y equals x squared. So at every point, this radius is x, this radius is x, this radius is x, this radius is x, this radius is x. So we're going to have, let's move the pi out. So this is equal to, let's write it here. This is pi times the integral of the big R. We said the big R is 2, so that's going to be 2 squared minus, we said the small r is any value of x that you can read down here. We're going to say it's going to be x squared, and then we have dx. And as you can see, this is the same thing as pi times the integral of 4 minus, now what is x squared? Based on what we're doing, you cannot use x squared because, I'm so sorry, this is dy. Okay, dy. So we cannot use x squared in this integral because we have to integrate with respect to y. So you have to change your x squared to write it in terms of y. And what did we say x squared was? X squared is y. So we're going to change this to y, and then we do dy. Okay, so now let's take the integral. Oh, by the way, what is the height? We're integrating all the washers starting from 0 to this point. We need to know what this point is. Okay, and that we can find. This point just goes parallel to this point, and this point is where x equals 2. Let's go back to the functions we have. When x is equal to 2, what will the y value be? The y value is going to be, hey, this is it. Y is going to be 2 squared, which gives us 4. So it's going to be 2, 4. So the height of what we're integrating is from 0 to 4. And that's what we're going to do. So this is the integral from 0 to 4. We should have done that. A to B. Let's do A to B here first. From A to B. And then we know it's from 0 to 4. 0 to 4. And then this is, so let's do this integration. We've got pi times the integral of 4 is going to be 4y minus the integral of y is going to be y squared over 2 dy. Oh, no more dy. Just got distracted. This has to be muted. Why are you making sounds? Mute, mute, mute. Okay. So we take the integral. We're going to have pi times. This is going to be, what's the integral of 4? That's 4y. What's the integral of y? That's going to be y squared over 2, evaluated from 0 to 4. Okay. Now if we do this, this is going to be pi times, well, this is 4 times 4 minus 0, so that's going to be 16 minus, if we square 4, it's going to be 16. 16 divided by 2 is going to be 8. Remember, I'm ignoring the 0 because if you put 0 in either case, you're going to get 0, so I'm not thinking about it. So what is 16 minus 8? That gives us 8, and times pi, that gives us 8 pi. Okay, so this is what you get if you use the washer method. Remember, we just used the washer method because this is a washer, like I explained, because there are 2 different radii. That's how you know it's a washer. The inside is closer to this axis of rotation than the outside. Then you know it's a washer. Okay, now, what if I don't want to use the washer method? I want to put a cylinder right in here. So let's say my plan is, or the instruction is, don't use the washer method, put a cylindrical shell. So we're going to imagine that we have a cylinder here. Okay, just imagine you have a cylinder that stretches out. So this is not the best cylinder. The cylinder has to be something in here. It spreads out to this, okay, like that. So at every point you're going to have a cylinder in here, and the cylinder will adjust itself, and the thickness of the cylinder, look, it's important for you to know what the thickness of the cylinder is. it is getting thicker along the x-axis. So this is what I usually tell myself. I'm going to do a setup. So let's still do the shell method. Shell method. Okay. So what I'm going to do for my setup is right from the start, I look at what the cylinder looks like. It is getting thicker along the x-axis, so my integration has to be dx. That helps me a lot because it is getting thicker along the x-axis. The next thing I'm going to do is to fix what my bounds of integration. They're basically the beginning of the area you're rotating to the ending of the area you're rotating. Always just look at the area you're rotating from 0 to 2. So I'm going to write 0 to 2. You can see it's different. This is 0 to 4. Okay, so it's from 0 to 2. I'm rotating, and that's it. What do you need to put in here? Now let's talk about that. I usually like calling it dv. Okay, so dv is what I'm going to put in here, because when you integrate dv, you're going to get v. Okay, what is dv? dv is basically the circumference of the cylinder multiplied by the height of the cylinder integrated along the thickness. So it is usually the circumference multiplied by height multiplied by the thickness. So what is the circumference of this? What is the height? What is the thickness? We already identified the thickness. That's delta x. Oh man, that's dx rather. So thickness is dx. I started with that, so that's done. What is the height of the cylinder? Now at every point, the height of this cylinder is determined by this function. So this cylinder that I put here cannot even exist because it has to be as high, just as high as this function. So this would be the cylinder at this point. At this point, this is going to be the cylinder. You see all the shapes I'm having? It's getting rough, okay? But that's the cylinder you get. This is the cylinder at this height. So the height of this cylinder is basically the height of this function, which is basically what you can read off of the y-axis. So the height of the cylinder is y. So now what about the circumference? Formula for circumference of a cylinder is a circle. It's 2 pi r. 2 pi. Now what is the radius of this? What is the radius of any cylinder? Basically it's 2 pi r. The r is going in this direction. Okay? So remember, it's a cylinder. We're not talking about a disc or a washer. It's a cylinder. So the cylinder has only one radius. Okay, and it's any point the cylinder is, if it's here, that's your radius, and that's the value of x you're gonna get. Okay, so it's gonna be just x. Beautiful. The only thing that is not okay is the y, because we're integrating with respect to x. So what we have here is 2 pi x times y times dx. Okay, but this x has to be changed. So because I cannot put x, I cannot put y here rather. What did we say y was? Y is x squared. So I think that's the only thing I need to change. Okay, and with that, we can say this is 2 pi x times x squared dx. And that's what I'm going to bring in here and integrate. So this is the same thing. Let's clean this up. This is 2 pi x cubed dx. So I'm going to clean this up and put the correct thing. So this is going to be 2 pi x cubed. Now let's integrate. This is going to be 2 pi integral 0 to 2 of x cubed dx, which is equal to 2 pi. If we integrate this, it's going to be x to the 4th over 4 from 0 to 2. This is going to be 2 pi. It's going to be 2 pi times 16 over 4, which gives us, that's 8 pi. 8 pi. As you can see, is the same exact answer we got when we solved using. For the second part, I'm going to rotate. Instead of rotating it this way, I'm going to rotate this way. So now, look, if I rotate this part here, because there's no hole, there's not going to be a hole here, this is what it's going to look like. So you see that the rotation is going to look somewhat like this. So I'm going to have discs stacked up this way. There is no hole in the middle because this is solid. Unlike the previous time when I rotated, that you could put something inside the bowl. And if you could put something inside the bowl, then it has to be a washer. But now everything is solid. Okay, there is no hole, there's no internal radius. So you notice I just have a bunch of discs stacked up. So we have to solve this using the disc. Well, I spelled my disc this way, I might change it to K. I'm so sorry. If you live in America, disc is D-I-S-C in the British spelling regime, whatever you call it. Okay, so we're gonna use the disc method. And I'm going to also show you that you could do it using the cylindrical shell method. So let's use the disc method first. So let's do disc. So remember that this is basically area times height. Because the height is not uniform, that's why we integrate. Okay? The height is not uniform, we have to integrate to generate the height. But the disc, the area of each face is just 2 pi. Whatever the radius is, you can see the radius is from here to this point and from here to this point. But because this is the real part, so this is where many students get this wrong. This is the original part. This is the part that is generated after rotation. So your focus should be here. If I want to determine the distance from here to here, what do you think I'm going to do? Remember, at every point here down here, you can call this x. X is changing depending on where you are, okay? Whether you're up here or down here, the value of x is changing. But the radius of each of the discs at each point, the radius of every disc that you're going to cut is the distance from here to here. The distance from here to here, which is 2 minus x. That's your radius. So the radius, remember that, your radius equals 2 minus x for this disc to work. Okay, so here, we're going to go here and say that the area is equal to, remember it is pi r squared, which is the same thing, since the radius is 2 minus x, that's going to be pi times 2 minus x squared. Well, we'll have to distribute this. Why? Because we can't leave our work in terms of x, because I already know that our differentiation of the thickness of the disc, they stack up along the y-axis, so it has to be dy. So I have to come here and say whatever I do will be the integral from the beginning to the ending. This is the beginning of our stacking from 0 to 4. Okay, thickness. Remember, you always go along with the thickness of the discs. Now, so 0 to 4 of the area. Okay, so what is the area? 2 pi r squared, which is going to be pi r squared. And if you FOIL this out, you're going to end up with 4 minus 4x plus x squared. Okay, now we can all put that, remember it's going to be dy. So this is going to be, let's put the pi outside here. So we're going to have 4 minus 4 times x. What is x? We can replace x squared easily like we did in the previous one with y. So we can put y here. But what will this be? X is the square root of y. So from here, since we know, we can say that the square root of y is equal to x. So we can write the square root of y. Okay? And then here we have plus. And this is the function, this is pi. This is the function you will have to integrate to get the value, the volume that we're looking for using the disk method. So the disk method is not always that straightforward. It depends on where you rotate, okay? Especially if you rotate along a line that is not 0, your radius will be that line minus something. Remember that. Or that line plus something, depending on whether the line is here or the line is here. Okay? If the original is to the left, it's going to be a minus. If the original is to the right, it's going to be reversed, x minus whatever that is. It may be difficult to integrate this, or impossible actually. I have to write this as an exponent. So this is equal to pi integral 0 to 4 of 4 minus, I write this as an exponent, that's going to be 4y to the 1/2, and this is plus y, and then I'm going to do dy. So this is equal to pi times, if we take the integral, this is going to be 4y minus, if we integrate this, remember what I've shown in other videos, to integrate any fraction is easy. Just say any function, any variable with a fraction exponent, just add the two together. 2 plus 1 gives you 3, and then you divide by 2. So it's 3 over 2. So it's going to be minus 4 times y to the 3/2 over 3/2. Okay? Plus, this is going to be y squared over 2, evaluated from 0 to 4. Okay, now, because, let's clean this up first. So this is going to be pi times, this integral is going to be 4y, and this is going to be, if you flip this, is going to be negative 8 over 3, so that's minus 8 over 3y to the 3/2, and that's going to be plus 1/2 of y squared. Okay, evaluated from 0 to 4. Whew. Now I'm going to do final evaluation. Because each term contains y, the 0 is not going to count for me, so I'm just going to focus on the 4. Now, 4 times 4 is 16. So this is going to be equal to 16. So there's pi. I'm going to put pi at the end. So here I have 16. Now, I put 4 here. The square root of 4 is 2. 2 times 3 is, 2 to the third power is 8. So that's going to be 8 times 8. That's minus 64 over 3. Okay, and then I have 16 is 4 squared divided by 2. That's going to be 8 plus 8. So what I have basically is 24 minus 64 over 3. That's going to be 72 minus 64. That's going to be 8. Oh, it's 8 over 3 pi. And that's the area that we're looking for. Okay, now we're going to do the shell method. Okay, let's see if the space will take it. Let's do the explanation here. So look at what I'm going to do. I'm going to insert a cylinder here. Okay, let's say this is a cylinder. Okay, like I said, the cylindrical method always works. It's a universal method. Okay, because every time you go round, you are creating a cylinder. It may not be perfect, but it's a bunch of cylinders with different radii and thicknesses that you're working with. Okay, so look at this. At any point, the radius of this cylinder is the distance from the center to this point, right? This is the part that we're dealing with. So the radius of this cylinder is basically anything. Remember, the cylinder will thicken out, okay? So the radius of the cylinder is just x. And that's the first and the most important thing. You're going to integrate with respect to x. So I'm going to say finally, when we do our integration, we're going to be doing the integral of this original portion. That's how you do for whenever you do the shell method. Just look at the original portion. It's from 0 to 2. So it's from 0 to 2 of the original portion, and you're going to be integrating doing dx. Your business is to find what the area of the circumference rather of the cylinder will be and what the height of the cylinder will be. The height of the cylinder is not a problem because the cylinder, you take the height just based on whatever this function is at this point. So it's just y. That's the cylinder. Whatever you get here as the height is y. So we know that the height of this cylinder is going to be y. So let's do the d here. So dv is circumference multiplied by height multiplied by thickness. We already know that the thickness is dx because that's how thick this is going to be. Okay, so we've already written that. We also know that the boundaries are going to be from the beginning to the ending of the original part that you rotated always. So we already fixed that. Now the next thing to do is to determine what the height is. We can say by all means that the height is whatever you get here. If you go higher, is still the value of y. Okay, so the height is going to be y. This is going to be dx. And now we need to find what the circumference is. Remember, the circumference is 2 pi r. So what really is the radius of the cylinder? Well, remember, just as we did, because you're starting from, this is the center, it's going to be the distance from here to any part of the cylinder you're dealing with. So it's still 2 minus x. So we're going to say that this is equal to 2 pi. This is going to be 2 minus x. And we said we have to do it in terms of x. Therefore, our y has to be x squared. Or x squared, y equals x squared, okay? And then this is dx. So this is the setup for this second part. It could be a little tricky, but it's circumference, 2 pi r, times this, times this. So if we clean this up, our dv is going to be 2 pi times, if we multiply this, you're going to get 2x squared minus x cubed dx, okay? And that's what I'm going to bring in here. I'm going to put the 2 pi on, okay, let's write everything. 2 pi times 2x squared minus x cubed dx. And we're going to have 0 to 2 of 2x squared minus x cubed dx, which if we integrate, I'm going to have 2 pi. And on the outside, the integral of this is going to be 2 times x cubed over 3. That's 2 over 3 x cubed. And then this is going to be minus x to the 4th divided by 4. That's going to be 1 over 4 of x to the 4th. Evaluated from 0 to 2. And because both terms contain x, the 0 is going to give me 0 in either case. So I'm just going to focus on the 2. And then I put 2 here. This is going to be 8. 8 times 2 is 16. 16 divided by 3 is 16 over 3. Well, there's nowhere to hide, so I'm going to write 2 pi multiplied by 16 over 3 minus, here I'm going to put 2, that's 16. 1/4 of 16 is 4. Okay, and this is going to be 2 pi times 16 over 3 minus 4 is going to be 16 minus 12 over 3. That's 4 over 3. 4 over 3. So this gives me 8 pi over 3. And that is the same answer we got when we used the disk method. Don't stop learning, because those who stop learning have stopped living. Bye-bye.